This is Copilot Explains, Episode 6, Error Troubleshooting in Jupyter Notebooks.
You'll start understanding it soon.
Explain this to me, won't you? It's all inside the code.
Hi there, I'm Carlotta Castelluccio, and in this episode I'm going to talk about error troubleshooting. Data scientists and AI engineers love to work with Jupyter Notebooks because they make it so much easier to look at the result of each and every data exploration step or data modeling experiment and take decisions accordingly. However, Jupyter Notebooks are not immune to errors, and sometimes understanding error messages and troubleshooting code, in particular if you are not a native English speaker or if you are a beginner, might be painful and time-consuming. In this video, I'll be sharing some tips and tricks on how to leverage Visual Studio Code and GitHub Copilot to increase your productivity, making it easier to analyze and fix most common Python errors in Jupyter Notebooks. But for now, let's explain. To encode some errors, we need some code. So let's imagine we are the co-founders of a startup supporting local farmers to categorize their produce, such as pumpkins, according to their origin, size, and other factors. So first thing first, let's head to Visual Studio Code and let's create our Jupyter Notebook. The code I'll be showing you in this video is available on GitHub at the link you see on the screen. Once you enable GitHub Copilot for your GitHub account, and once you install the GitHub Copilot chat extension in Visual Studio Code, you can open a chat window and use the /create notebook command to create a new Jupyter Notebook. Here, we are asking to create a Jupyter Notebook including one code cell to import pandas and numpy, which are two common Python libraries for data science. Running this command created a template for my Jupyter Notebook with a Markdown cell and a Python cell to import the requested libraries. At this point, I can import my dataset in a CSV file format from a URL. Now that we imported the data, let's add one line of code to print the first few rows to have a look at our data. In my haste, I did my first mistake and I got an indentation error. Where in other programming languages the indentation in code is for readability only, the indentation in Python is very important. Python uses indentation to indicate a block of code, so you have to use the same number of spaces in the same block of code. Otherwise, Python will give you an error, like in this case. But if I'm new to Python and I come from R, for example, or F#, this might look like a weird error. One of the new features you can leverage in these cases is Visual Studio Code is the Fix using Copilot button. This feature interrogates GitHub Copilot under the hoods to get a recommendation. Outputs a side-by-side view of your code before and after the proposed changes and let you accept or deny the suggestion. If I run again this cell, this will be executed successfully. This dataset is a bit crowded, with lots of features and some of them are full of missing values. So let's clean it a bit by selecting only a subset of features we'll be working with and filtering out null values. Let's now look at the resulting data by plotting it. In particular, let's visualize the distribution of pumpkins variety and pumpkins color using a Python library for plotting called Seaborn. As you can see, I'm getting a new error now, which refers to a module not found. In particular, Python is not able to find Seaborn in my environment. Now, I'm using a virtual environment here, which is a best practice to isolate the packages installed in this workspace from others. But I created it some time ago and I can't remember which packages I have installed into it. So let's see if I can get support for the GitHub Copilot chat. And since the ask regards Visual Studio Code, let me use the /vscode command and let me ask how can I see the installed libraries in my virtual environment. So GitHub Copilot is giving me some instructions to achieve this result. And in particular, it is suggesting me to open a new terminal, then activate my virtual environment, and then use the pip-freeze command to see the list of packages installed in my environment. My environment is already active, so I can jump to the next step and go to my terminal and launch the pip-freeze command. So let's do that. Here's my list. And I can double check here that there are the packages that I used in the code earlier, like pandas and numpy, whereas I cannot find the seaboard libraries in the list, which is sorted in alphabetical order. But let's come back to the chat now, because GitHub Copilot is suggesting me exactly the question I have right now. So how can I install a new library in my virtual environment then? And here's the reply. I can use the pip command, and GitHub Copilot also outlined me an examples. But in my case, I need to install Seaborn, so I will launch the command on the terminal, pip install Seaborn. Cool. Once I'm done with installing, I can come back to my code and double check that running again my code cell will execute successfully, and that I can get my plot representing the distribution of varieties and colors of my pumpkins dataset. Let's now move forward and let's display our clean dataset. As you might notice, this dataset contains all categorical values. Working with categorical data is intuitive for humans, but not for machines. Machine learning algorithms work well with numbers. So let's employ encoding to the original dataset to turn categorical data into numerical data without losing any information. For nominal variables, we'll be using the scikit-learn one-hot encoder, representing each category as a binary column. While for features whose values follow a logical ordering, we'll be using the scikit-learn ordinal encoder. By executing this code cell, I'm getting a name value error. Name item size categories is not defined. Some of you might already notice what's the issues in this code block, but let's suppose I'm not getting where the problem is. I need a hint. So I place the cursors next to the last line of code. I click Ctrl-I and I get an inline chat where I can ask GitHub Copilot to explain the error message I'm getting. So Copilot is telling me that this error occurs when you try to use a variable that has not been defined or is out of scope. In this case, the problem is with the item size categories variable. And it also suggests me a code that I need to add to define the item size categories in a way that it is declared before use. This looks like what I'm doing, so let me double check the difference between the code Copilot suggests with the code I have here. Keeping aside differences in the label's naming, having these two side by side helps me see that in my code block, the name of the array I declare doesn't map to the one I use in the initialization of my ordinal encoder due to a typo. There's an extra S, and by removing it, I can run the cell successfully. Once we have the two encoders for the features of the dataset, we can use the scikit-learn column transformer object to combine them into a single step and apply the transformation to the dataset. After having encoded the features, we can encode the label, which is the column color that has a binary value, white or orange, and then merge the encoded features with the encoded label into a new data frame. In the previous steps, we have explored and preprocessed our data. Now we are ready to build a predictive model able to categorize the pumpkins according to their colors. To do that, we need to split our preprocessed dataset into two subsets. One will be used to train the model, and the other one will be used for evaluation purposes. Also, we need to specify the color column as our label Y. Now, since this is a binary classification problem, we have two possible categories for color, white or orange. We can train a logistic regressor. Also, let's compute the evaluation matrix against the evaluation subset, and let's print the results. Now, since this is the core part of our solution, we would like to have some clear documentation to accompany the code. We can accelerate the tedious but essential task of documenting our code with the GitHub Copilot /doc command. Let's open the chat again, and since it's a bit messy right now, let's clear it with the /clear command, and then let's select the code chunk we'd like to document and let's type in the chat the command for documentation, so /doc. In this case, the output of Copilot is exactly a description in natural language of what the code selected is doing. So since I'm in the Jupyter Notebook, I can copy-paste this output of GitHub Copilot into a markdown cell, and this will serve as documentation of the above code. In this video, we provided some tips and tricks to improve your productivity when working with Jupyter Notebooks, and we demonstrated how you can get the support you need to address common errors in your Python code without leaving your development environment, avoiding context switching. Now, how would you explain error troubleshooting in Jupyter Notebooks? Do share with us your approach by creating a video, a blog post, or a GitHub project, and add the link to your content in the comments. We'll pin our favorites so more people can see it. Thanks for watching this video, and be sure to catch the other episodes of the series.